NASA has experienced a lot of successful missions in its history of launches as one of the pioneers of study beyond the bounds of Earth. However, there have been a few snags along the way, one of which was when NASA lost touch with their Voyager 2 spacecraft for nearly a year until November 2021, when they were able to reestablish contact with their craft. Welcome back to our channel, ladies and gentlemen, where today we'll be telling you the amazing story of how NASA was finally able to reestablish contact with the Voyager 2 after having no form of connection for almost a year. There have only been 5 successful spacecrafts that have had enough energy to exit the gravitational pull of our solar system since mankind began launching spacecraft. This list includes both of the Voyagers. Voyager 1 has exceeded all previous spacecrafts and is now the furthest away at 22 billion kilometers from Voyager 2, which is only 18.8 kilometers away. Since the coronavirus outbreak in mid-March, NASA has been unable to communicate with Voyager 2, but an improved deep space network dish made a successful connection on November 2nd. The reasoning behind distance and communication is that the further a spacecraft is from you, the further a signal you transmit must travel before reaching it. The longer it takes to arrive, and the lesser the signal's power is when it arrives. Because light signals spread out in 2 dimensions perpendicular to the spacecraft's line of sight, if one spacecraft is twice as far away as another, the distance between them is doubled. The time it takes for a light signal to travel to it is twice as long, and the signal power it receives is only 1/4 as strong. The amount of energy used to deliver these messages is likewise much higher. The distance is the same as laying 500,000 Earth-sized planets next to each other and back. An electromagnetic signal is simple. It expands out in spherical shape from its source, whether you detect it with a fracking lens or reflecting dish or a linear antenna as NASA did. Furthermore, whatever observation you make, both from the terrestrial and celestial sources, has some underlying background noise, and your signal must cross a specified threshold to be noticed, rising above the noisy background. That means larger detectors are better for receiving, and a higher-powered transmitter is better for broadcasting. Unfortunately, NASA spacecraft that have already launched will not be able to have their hardware changed in any way. They will be stuck with the technology they were given once launched. To make matters worse, the spacecraft are propelled by radioactive sources in which a specific element such as plutonium-238 decays radioactively and releases heat, which is subsequently converted into energy. More material decays over time, lowering the amount of power available to the spacecraft for both broadcasting and receiving signals. As the amount of heat energy produced by radioactive material diminishes, the conversion of heat energy into electrical energy becomes less successful. The material decays with time and loses efficiency at lower powers. As a result, the quantity of power made available from the generators to the spaceship has decreased. As of 2021, the plutonium-238 aboard is only supplying 69% of the initial thermal energy, resulting in only around half the original output power. Despite the fact that Voyager 1 and 2 are 43 years old and have traveled farther from Earth than any other operational spacecraft in history, we have yet to lose contact with them. The logic is straightforward. As our transmission and reception skills improve on Earth, we will be able to send out more powerful signals that will be received by these remote spacecraft, as well as better identify their responses even at low levels. The key is NASA's Deep Space Network. This is a radio antenna network designed to communicate with humanity's distant spacecrafts. 3 huge radio antenna installations are located throughout the world, one in Canberra, Australia, another in Madrid, Spain, and a third in Goldstone, California. These 3 locations are almost equidistant across the globe, guaranteeing that any given time, at least one of the antenna has a clear line of sight to the spaceship. Of course, this is not always the case, but it is a majority of the time. You might have observed that facility in Canberra, Australia is the world's sole one in the southern hemisphere. The Australian dish would be the only method to communicate with a spaceship that is extremely far south, so far south that it is invisible from California or Spain. While all 3 of these facilities have the potential to communicate with Pioneer's New Horizon and Voyager 1 spacecraft, Voyager 2 stands out for one reason: its 1989 flyby of Neptune and its massive moon Triton. Even now, humanity's first close encounter with our solar system's 8th and final planet is the Neptune expedition. As far as we know, this is the last one, along with Triton, the largest known object to have originated in our Kuiper belt. Neptune's ring system, a smaller number of moons, and a range of characteristics on Triton, such as Cryovolcanoes and varied terrain were all discovered during that flyby, similar to what we would find 26 years later when New Horizons passed by Pluto. Voyager 2 had to fly past Neptune's North Pole in order to gain a close look at Triton, which deviated Voyager 2's route far south of the plane in which the planets orbit the Sun. It has remained on that trajectory for the past 31 years, with the exception of one dish in Australia, rendering it invisible to all members of the Deep Space Network. Since mid-March 2020, that dish, which contains the radio transmitter required to communicate with Voyager 2, had been shut down for maintenance. The dish is an engineering marvel in and of itself. A world-class radio antenna with a length of 70 meters had been built. Among the instruments linked to it are 2 radio transmitters, one of which is used to deliver commands to Voyager 2. As of early 2020, that instrument was 47 years old and had not been replaced during that time. It also processed out-of-date heating and cooling systems, inefficient electronics, and a power supply system that prevented any future upgrades. Fortunately, it was agreed to upgrade them all, allowing NASA to do something no other organization can: send Voyager 2 directives. While the spacecraft continues to provide health updates and science data to a series of similar smaller dishes in Australia, it is unable to accept commands and will continue to do so until new commands are received. On October 29, 2020, enough of the upgrades had been completed for Voyager 2 mission operators to perform a critical test, sending a set of orders to the spacecraft for the first time since the renovations began. The project manager of the Deep Space Network at NASA, Brad Arnold, said, "What makes this task unique is that we're doing work at all levels of the antenna, from the pedestal at ground level all the way up to the feed cones at the center of the dish that are extended above the rim." Despite the fact that a signal from Earth to Voyager 2 takes around 36 light hours to travel round trip, NASA deemed the test a success on November 2. The signal from Voyager 2 confirmed that a call had been received and the commands had been carried out successfully. This test communication with Voyager 2 definitely tells us that we're on track with what we're doing, Arnold says. NASA has hailed this makeover as one of their most significant achievements in the last 2 decades, as allowed them to reestablish communication with a piece that many had written off as hopeless. Voyager 2 and other escaping spacecrafts' power levels will continue to diminish as they get further away from the Sun, making it more difficult to broadcast commands and receive data. However, as long as the Deep Space Network antenna remains operational, even at extremely low and wasteful power levels, we may continue to update and enlarge them in order to do science with them. As long as these satellites remain operational in some form, simply updating our facilities on Earth will allow us to collect data for years, if not decades to come. That is all you need to know about the Voyager 2 and how NASA managed to reestablish contact with it after almost a year. What do you think about the Voyager mission regarding their age and reducing power? Let us know in the comments below. Make sure to like this video, subscribe to our channel, and turn on notifications to never miss another update. We wish you luck and goodbye.